19. On a level horizontal table, a toy race car of mass m moves with constant speed v around a flat circular racetrack of radius r. The car is now going around a banked curve, as shown in the figure above. The banked curve is higher toward the outside of the circular turn. The car can now travel at a higher speed without sliding because the banked curve, well, there are several options here, but the most important part is that we must depend on a free body diagram to determine the situation. A top view of this situation indicates a circular path going around like this, so that the centripetal acceleration is this way. And so if we look at this from the front, there are several forces that are evident. In the first place, we have mg. Then we have the normal force, which is no longer vertical. It has a degree of inclination, which means that it has x and y components. Finally, for a higher speed, you have a friction force that is supposed to be pushing towards the center, because the tendency of the car is to get off the curve. And so we cannot say that there is an increase in the coefficient of friction, because that depends on the materials involved, the rubber in the tires and the asphalt in the road. Increasing the momentum of the car is irrelevant for our purposes. The banked curve allows a component of the normal force to point toward the center of the track. That is correct. It doesn't allow a component of the weight to point toward the center of the track. Remember that the center of the circular path is still in a horizontal direction and the weight is vertical. And finally, there is no gravity doing work on the car, because the gravitational force is downward and the motion of the car is forward. So our best answer is option C.